Okay, now the standard form of the quadratic function is ax squared plus bx plus c. When, of course, the coefficients a, b, and c are in general real numbers. Specifically, a never is zero, never is missing, because if a is missing, entonces no quadratic. So the most important, guys, in this function is that part, the x squared term. Okay, now this is one way, very popular. However, we have another, que f of x equal a, by the way, this a is the same a of this, x minus h squared plus k. This is vertex form. And this is important for several reasons. So what is the most important? No, depending. Square here. Who is h and k? Que es a new parameter, no? Or constant. Is the vertex. That is the reason that the name is vertex. Vertex, what is vertex? The word vertex indicates this is a parabola. It's a parabola, and that point is a turning point, is the vertex. And the component for the vertex is h, k. Keep in mind that h is the x value and k is the y value of the vertex of our quadratic function, que by the way is a parabola. Okay? Entonces, well, advantage and disadvantage you see now. I bring 3 examples. An application to illustrate very well this idea. Okay, look. Number one, important is determine the vertex. Any problem of the quadratic function, the super important number 1 point is determine the vertex. The vertex is easy, super easy when you have the vertex form is h, k. Boom, that's it. When it's a standard, no. But there are connection between h and k and a, b, c. And the formula are, look, to find the h, the formula is easy. It's minus b over 2a. Okay? Now to find the k, their formula, but it's a little bit complicated. Much better is plugging in the function, plugging in h value into the function f. And you determine this. So you see example in which I give you the example in vertex form. So now determine the vertex point is super easy. You see using your eyes who is h and who is k. That's it. And the scenario gets a standard. Well, we compute it using that formula. Formula 1 and Formula 2. The Formula 1 guy is the most important formula today. We using in the application, we using in the graphic of this, we using every day. Okay, now after that, important, A is another important parameter, que by the way, A is the same. So A is this A, que is the same A, no differences. If A is positive, that indicates us que the parabola open over. Putting off your microphone, please. All right, let me see who. Okay, thank you. Okay, so how do you know in what direction open? Open. Okay, Sandra. Okay, open. Don't worry for the attendance guy because I take your name. So a sky on the background, write the name of the NA student is present in this meeting. So I watching this, I put in my spreadsheet Excel. No? Open over when A is positive. So you see the sign of A. See A is 2, open over. See A is minus 2, open downward. See A is negative, is open down, open down, open down. And remember, illegal, totally illegal, que A is 0. No, A never is 0 because A is 0 is no quadratic function, it's a linear function maybe. Okay. Now another important thing that we analyze in any example is the axis of symmetry. Axis of symmetry. What is that? Bueno, actually it's a parabola. Doesn't matter if it's open up or open down. The axis of symmetry is always a vertical line passing through the vertex. And this split the parabola into equal parts. That is the reason it's symmetry. And what is important? Well, it's important because sometimes I have information about some point here, but it's complicated or weird, find the other, but you can get that distance is the same distance, symmetric. And that distance is that distance, symmetric. Likewise, it doesn't matter if it's open and down, we have axial symmetry, I repeat, it's a vertical line passing through the vertex. Okay. One more we need to complete the word in order to do the graphic. Is number 4 is compute two important points always in any function. Okay, the y-intercept. Y-intercept is the point in which the curve, the parabola, in that case, crosses the y-axis. And what is the formula, professor, to find the y-intercept? One, you evaluate in 0. You evaluate in 0, and the number is given here. Suppose, I don't know, 4. In one specific example, the point is 0,4. Because the supposition was okay, x is 0 and y give me 4. This is arbitrary. I put 4, 40, whatever. And the x-intercept, oh, it's easy. The formula is different. You take the function and you enforce it to be equal to 0. Basically, for finding y-intercept, you enforce x0. However, for finding x-intercept, you enforce y equals 0. So this is a little bit more complicated because we have equation and you need to solve the equations. Actually, the thing we are doing so far, when you have solution of the quadratic equation, is solving quadratic equation. So let me explain more clear. So when you're solving the quadratic equation, the thing that you are doing is find the x-intercept of the quadratic function associated with this quadratic equation. So we have different possibilities. You know. We have, for example, the parabola. Suppose the axis x and y. And we have three possibilities. Suppose que the parabola, que is the most popular, look like that, and cross in 2 points. This is the x-intercept. Yes, because the solution of the quadratic equation associated with the quadratic function give me two solutions, two real solutions, two real. Suppose, I don't know, 1, 3. X equal 1 when you solve the equation. We have another, no two more popular, but it's possible. We have only one. Suppose 1, 2, 3. It's a one solution, one real solution. And suppose the last scenario is that we have no real solution. No real solution. So what is the reason? How you determine this? One, you determine solving the quadratic equation. But one intuition to find this without solving the quadratic formula is, remember the quadratic formula is minus b plus or minus square root b squared minus 4ac divided by 2a. And this expression is extremely important inside the right, determine the behavior of the solution. If this expression, let me call capital D, b squared minus 4ac, give me positive number, because we have that solution, two real solution. Si D is equal to 0, is this possibility, only one. It's obvious, no? Because that part disappears, no? And give me only minus v over 2a. And CD is negative. Wow, so we have the famous solution negative, que es complex, no? Or imaginary. Therefore, we have no real solution. Okay. By the way, let me take advantage of this idea. Sometimes ask you in the test and the Alex about, let me try one more 5 option. Domain, range, and optimization. Let me explain a little what is that. In the parabola, for example, that parabola, or let me put it generical. For example, one parabola like that. Suppose that parabola. Intentional, I put the arrow. Why? Because that indicates us that we are doing the sketch of the one portion of the parabola. That parabola continues forever to the right and to the left. Therefore, always 100%, the domain is all real number. Because remember, when you project any point onto the x-axis, you get the entire all real number. Positive infinity, negative infinity. However, the range, no. Why no? Because depending, see the parabola open, upward or downward. In that case, it's upward. So from the vertex here, from the vertex to when you're projecting, of course, you get only that part. Look, let me see that part. So from this value, so the part I highlight in green color is a range. Suppose, I don't know, suppose hypothetically that this value is -2. Entonces, the range is bracket -2, infinity. This is clear, right? Now, optimization, what is that? Well, depending on the problem and the word problem we are doing in the last part of this section, word problems, sometimes we need to find optimum value. Optimization means the best value, no? Because sometimes it's a maximum or minimum, depending on the problem, no? See, in the problem talking about profit, I would like my profit to be maximum. However, see my problem talking about, sorry, lay professor. Okay, Jamie Martinez, no problem. See the problem talking about cost, money. So the money that you need to spend, then you need to minimize. Yes, profit, you maximize, no? Because good, no? I want too much of the good thing, and I want less of the bad thing. So now, that depending in what direction open the parabola. See the parabola open in my problem. Open. Remember two possibility open. Suppose that this is my parabola. Okay, open over. It's obvious that the optimum happen here. Okay, would be the minimum. However, see the parabola open downward. So the optimum is this. Always the optimum is the vertex. When you see optimization, you need to find the vertex. I promise, guys, that the test number 2, written test, and also some problem in Alex, maybe at the beginning you don't understand very well. because the problem is optimize. Try to find the maximum value. Immediately, you know, que si es quadratic function, the maximum value occur in the vertex or the minimum, depending what direction open the value. So far, everyone follow me? Come on, guy, say something.
Yes.
Yes, okay. Example one. Example one. What is the idea in this example 1, 2, 3? Okay, I bring for you now. Is I give you the equation of the quadratic function. You determine si es expressed in standard or vertex form. And you determine everything. 1, 2, 3, 4, 5 situation. And finally, we are doing the graph. Okay? So determine everything. 1, 2, 3, 4, and 5 steps. Okay, we discussing now here. And finally, do the sketch. The sketch you are doing, of course, why not using decimals? Okay? Any graph you using decimals. So you compute something in the piece of paper, and now I go to this information. I do the graph in decimal and verification. Okay, everything we are doing is right. Okay, suppose the first example. The first example is f of x equal minus 2 parentheses x minus 1 squared plus 8. My equation number 1. In what format, in what form is expressed this function? In vertex or standard? Big question mark. Vertex or standard? Come on, answer me.
Vertex.
Say again?
Vertex.
Vertex. Very well, very well. It's obvious when you see parentheses, something is vertex. Okay, entonces, who is A? Who is H? And who is K? Be careful because it's a little bit tricky. Who is A? Who is A? You compare. Look, compare the general format for the vertex form is A parenthesis x minus 1 squared minus hello minus h squared plus k. Okay, and you compare. Who is A? Minus 2, right?
Yeah, two, not minus 2.
Minus 2. Be careful. This is mathematical. One sign you are doing wrong, you screw up everything. Entonces A es minus 2. Who is H? Who is H?
X minus 1.
No, a positive 1. Because the equation, this is tricky. I know that the equation normally have a minus, f minus, therefore h is positive 1. So what is the mnemonic divide to recognize quickly and perfectly the h? As you see in the parentheses, x minus 1 squared, it's obvious that h is 1. However, if you see x plus 1 squared, h is negative 1. Why? Because the equation contains one, the original equation contains one negative. When you see positive, it's because we have double negative. Negative of the h and negative of the equation together become positive. So opposite sign in h. However, in k, no. In k is the same because it's plus here. Makes sense or no?
Yes.
Okay. Now, question number 1. Where is located the vertex of this parabola? At what point? Vertex. At the point, something, comma, something, no? H, comma, K. Who is H?
1.
Who is K?
A.
That's it. This is my vertex. Okay. My first step. What is my second step? In what direction open, no? Well, let me check it. Checking the oil. Checking. The second is about, yeah. in what direction open? What do you think about in what direction open? That parabola open, parabola open. In what direction open? What is the parameter that have the control? In what direction open? Is A. When the A is negative, in what direction open?
Downwards.
Downwards. So my parabola, schematically, I am doing that way. By the way, this point is this one. Everyone follow me?
I have a question, Professor.
Go ahead.
Why would it go downwards?
Because A is negative. So the control in what direction open the parabola is determined by the sign of A. When the A is positive upward, when the A is negative downward. Cool?
So for K, it's -8.
No, A. So the control is A. You analyze only A. Forget about K and H for a moment.
Oh, A, okay.
A.
Okay.
No K. A, B, C, D, A.
All right.
Okay. Now, number 3 is about the axis of symmetry. Axis of symmetry. Axis of symmetry always is a vertical line. Any vertical line, you know, that the equation is x equals something. And this something is h. And h, in our example, is 1. So the equation for the axis of symmetry is the vertical line can split the parabola in 2 parts. So this equation, I know very, very well, is a vertical line passing through that point. Okay, and split the parabola into 2 parts. Now, one more we need. Number 4 is the y-intercept, x-intercept. Easy. Y-intercept, evaluate the function as 0. When you evaluate the function as 0, let's do it. Is you replace x for 0, entonces -2, paréntesis, 0 minus 1, square plus a. Be careful with the sign. Order of operation, PEMDAS, paréntesis first, 0 minus 1 is -1, -1 is square, exponent is +1, and +1 times -2 is -2, and -2 plus 8 is +6. Therefore, my point is the point 0,6. Okay. You follow me?
Yes.
And the
Wait,
excellent.
can you do step 4 again? Like, can you
Yeah.
explain it one more time?
You want, can I explain the order of operation? The order of operation, right?
Yes. Yeah.
S minus 2, Mr. Look. 0 minus 1 is -1. And -1 squared is +1. And -2 times +1 is -2. And -2 plus 8 is +6. Cool?
Yes.
Okay, now let's do it now. The y-intercept is a little bit more complicated. Why is more complicated? Because you set out like that. You copy the functions and you enforce it to be 0. But what my function, I forgot. Oh, my function, it was -2 x minus 1 squared plus 8, and you enforce it equals 0. Okay, that part. I copy the function, that part. And the right hand side, you put 0. Okay, this is easy for us because it's a quadratic equation. And by the way, I can use in a square root method. I put -2 parenthesis x minus 1 square equal -a. I move positive a to the right hand side like a -a divided by -2 both sides, division. So we have x minus 1 square equal +4, no? Because a divided by 2. Negative divided by negative is positive. Now we are ready to apply a square root both sides. Because remember, what is my goal? my goal is x. So x minus 1, you know very well what's happening in the square root and square on those each other. And square root 4 is 2, but don't forget, please, plus or minus. Exactly the same we are doing in the chapter 1. Now finally, x is equal plus or minus 2 plus 1. We have two solutions. Okay, and solution is you take the positive sign, plus 1 is 3. And you take the minus sign, minus 2, plus 1 is negative 1. Wait. This idea is not completed because I need a point, and the point have two components. No? The components are 3, 0 and negative 1, 0. Because according to the supposition, you declare y 0. Okay, this is the formula, no? Look. So now we have a plenty information to start doing the sketch. I don't know if it's good or not doing by hand. Yeah, this is easy. Let me try to find one rectangular coordinate system. Let me see if I have one here or not. Oh, yeah, let me see. Stop. Maybe here. Oh, let me see. Maybe here. There you go. It's not good, but it's something. Of course, never we are doing this. This is the first time that we are doing by hand, because in the few seconds, I go directly to the decimal if we are doing decimal. No? And in decimal, remember you can download the image, the image, and you attach and your written test. Okay, good. What information? Let me summarize. The important point. What is the important point? The vertex, that one, this guy. 1, I plot that. Well, this rectangular coordinate system is no good. Yes, no good because we have only to the 6 and you need 8. Okay, no problem. I try to extend a little bit the y-axis. A little bit. Okay, so I suppose que this is 6, this is 7, and this is 8. 8 and 1. 8, 1. Bang! This point is the point 1, 8. 1 x value, 8 y value. I have another point. I did that. Boom. Now here, 0,6. It's a y and a z.
Professor, you mute yourself. Professor, you're muting yourself.
Why? I don't know why.
You mute yourself.
You or me?
No, you did. Yeah, you did.
How? You see how when I did that?
And no.
Okay.
Yeah, it was on the West Coast.
Sometimes happen, yeah, I don't know why. I need to investigate why. Thank you. You help me. What's your name is?
Leslie?
Professor, it gives me the option to mute you, so somebody probably clicked it by mistake.
Oh, okay. Okay, no problem. You continue watching the whiteboard or not?
Yeah, right now we can.
Okay. Now you hear me. So now that point was 3, 0, and a negative 1, 0, bang here. I have, some idea how look like my parabola. Open down, the vertex is here, vertex here. The passing through this point. I try to do my best, but it's impossible to do it the best. Go in that direction. Now I have no information here, but okay. I can using the idea for the axis of symmetry. What is the axis of symmetry? This line. Let me use in green color. Axis of symmetry is a vertical line passing through the vertex and x equal 1. Entonces, my parabola is symmetric. Therefore, using my common sense and my imagination, I can determine another point here. Yes or no? Que it's a point 2,6. I guess so. Because it's the same distance from the vertex is 1 and the same y component is 6. Okay, more clear now. So now my parabola look like that. Cool?
Cool.
Domain range and in this case maximum. Domain is always all real number. We have no restriction, we have no division by 0, we have no square root negative number, no. And range is bracket 8, que es this component, or no, mistake, from negative infinity. Remember, in the interval notation, you put the lower bound first, comma 8 bracket. So in other words, my y value go from 8 and going down. This is the part I highlight in green color is the range. Of course, we have no parabola in 9 and 10 and 11, no? It's obvious. No? And the maximum is the value 8. The value 8, yeah, the value 8 is the maximum at x equal 1. It's maximum because it's the parabola que open down. No? Any question, guys? However, I don't feel good with this idea. No, I want to switch into Desmos to see more clear on Desmos. Desmos now. Let me share the screen of Desmos. Switching to Desmos. Do you see Desmos now? No? Yes?
Yes.
Yes.
Okay, cool. So now I have the example 1. The example 1 was this equation. I copy the equation. I plot the point in the order separated by a comma, no? 1 comma A, 0.6. So 1 comma A is the vertex, 0.6 is the y-intercept, 3.0 and negative 1.0 are the x-intercept, and I have 2.6 is a arbitrary point that I found using the symmetry axis. Look at that. Bang. Beautiful, no? Okay, look at that. This is my parabola in blue color. And the point, the vertex 1 comma A, you see, open, down, because A is negative. The y-intercept was 0.6. And the x-intercept was 3.0 and negative 1.0. And you obtain the other extra point. Actually, we have 5 points, no? 2.0, because I take advantage that distance is exactly the same that distance. In conclusion, any point are symmetric with respect to the axial symmetry. And the axial symmetry, like always, is a vertical line. I put the dotted line in black color. Cool? How do you feel? Clear? Or confusing?
Clear.
Let's do it another more little bit complicated problem. I want to come back again to the whiteboard. Do you see my whiteboard?
Yes.
I want to erase everything. Example 2 now. Example 2 is, okay, the function is g of x, another name, is equal 3x squared plus 12x plus 5. I repeat again the equation. This is the vertex form or standard?
Standard.
Exactly, estándar, very well, very well. Entonces, inmediatamente que yo recognize, oh, es estándar, entonces ahí determina que A es 3, B is 12, and C is 5. I have no idea about H and K, no idea. But I need, of course I need. Remember, the most important point in the parabola is the vertex. So the step one is compute vertex. Okay, but don't worry too much because we have formula. What is the formula? The formula for H is minus B over 2A. Okay, entonces who is B? Be careful with the sign. Minus B is 12. 2 times something, que 2 is A is 3. According to the order of operation, this is 12 divided by 6 is minus 2. Wow, H is minus 2. To find the K, we have no formula. The professor says it's complicated, okay? But it's easy because you plug in 2 into the function, que es H, minus 2, sorry. Remember, H and K belong to the same point. Therefore, this is the first component, X associated with the vertex. To find the second component, you evaluate in the function G. Then you evaluate the function G, evaluate minus 2, is 3 times minus 2 squared plus 12 times minus 2 plus 5. Let's do it. Minus 2 squared 4. And 4 times 3 is 12. Minus 12 times 2 is 24. Plus 5. And 12 positive minus 24 is minus 12. Plus 5 is minus 7. Oh, so K value is minus 7. Therefore, the super fantastic conclusion is my vertex is located at the point minus 2, minus 7. Anyone follow me? Do you understand the idea or no?
Yeah.
Okay, now, super important. This is equivalent 100%. This is a standard. I want to write the vertex form. Now, the A is the same, it's a 3. Open parenthesis. Remember the format for a standard is A, X minus H, square plus K. Entonces, X, que es el variable, H is minus 2. Okay, plug in minus 2. Double minus become positive. Do you see that or no? Plus, or no plus, it's minus because plus and minus is minus. Bang. And now you can write G of X, another way to visualize, to express it algebraically, the same as 3 times X plus 2 squared minus 7. This is equivalent to this. 100% equivalent. Standard and vertex form. Okay. It's clear or confusing?
I have a question. When we
Go ahead.
The homework or any exercise and they give us the standard form, do we always have to like rewrite it as an answer in the vertex form or no?
Not necessary. Remember, our goal is determine the vertex point because my final goal is do the graph. But by curiosity to illustrate this idea, I do the conversion. And this conversion we are doing in that way using the formula because I consider it is easier. However, we can do it using complete square. So you feel strong and complete square. But in my opinion, it's easy. That formula. That formula is the key. Mira, that formula is the key. I don't know si I answered your question, Miss.
Yes, you did. Thank you.
Okay, cool. Now, I complete the first step. The second step is in what direction open our parabola? Open up or open down? What do you think?
Open down.
Open down. Why? I need to understand open down. Why? What is the value of the A?
3. So
3 is positive.
Open up.
Open up, no?
Yes, open up.
Open up. Open up. Because A is positive. Remember, In what direction you have 50-50, up or down. Positive A, I don't care BC. BC no participate in this analysis. And the only parameter que participate in analysis is A. Si A is positive, up. Si A is negative, down. Cool. Okay, one more thing we need. We need the axial symmetry. Okay, it's easy. Axial symmetry always has a vertical line. And the equation for the vertical line is x equals something. And this something is h. And h in our problem is -2. Look at that. This is my equation of the axial symmetry. Cool. Number 4. Y and z, x and z. Remember the formula. Evaluar en 0 is to compute the y and z. Okay, so this is the challenge. Well, what equation? Well, no, in this case, the name of the function is not f, it's g. I change the name. It's not important, but it's okay, g. What equation I prefer? I prefer plugging in inverted form or standard. I recommend standard. Why? Because you replace x for 0, that part disappears, it's just fine. Basically happen, always happen, que C value. The y and z. Well, the x and z is more complicated. So the point is the point 0,5, no? My parabola passing through the point 0,5. And now to find the y and z, you take the equation. I prefer, well, either way, I prefer using the standard because I have a habit to solving the quadratic equation using the quadratic formula. No? So it's 3x squared plus 12x plus 5 equals 0. Okay, one more time. I detecting A is 3, B is 12, and C is 5. So now I'm plugging into my famous quadratic formula. B squared minus 4AC divided by 2A. Okay, this is minus 12. Plus or minus square root 12 squared minus 4 times A get 3, C get 5, and everything divided by 2 times 3. Okay, it's easy. I focus C, remember, and the expression inside. Yeah, that one. 12 squared is 144. I put in my calculator so I don't remember. Minus 60. Because it's 4 times 3 is 12, times 5 is 60. Now subtraction is 84. And don't forget the square root. Entonces 84 is no, unfortunately, is no perfect square number. But don't worry, we try to using the calculator or with simplification a little bit. Let me try to do my best. This is, it's obvious that the solution is irrational number. It's minus 12 plus or minus square root 84 divided by 6. Because 2 times 3 is 6. And 84, suppose que no calculator for a moment. You divide by 2 is 42. Divided by 2 is 21. And 21 is 3 and 7. This is a primary factorization for the 84. And I can detecting a couple of 2. A couple of 2 inside the radical is 1, 2 outside the radical. Therefore, we have so far one small simplification is minus 12 plus or minus 2. This 2 is this 2, radical 21. And 21 is impossible. Doing more simplification because 21 is formed by 3 and 7. We have no couple to simplification. Divided by 6. And finish? No, because I can see that you 12, 2, and 6 as even number. So you divide by 2, so it's minus 6 plus or minus radical 21 over 3. I suppose you understand very well this. Yes or no? Yes or no? Yes or no? Okay.
Yeah.
Now, I have totally lost because I have no idea of this number, but no problem. To get geometric idea about this number, I separate into pieces. You put minus 6 plus radical 21 over 3 and minus 6 minus radical 21 over 3. Remember, we have double sign, plus and minus. And we compute using the calculator now the decimal approximation. This is the exact solution, but I need approximate solution because I want to plot graphically. And the solution are minus 0.47 and minus 3.53. Therefore, my x-intercept are the point minus 0.47, 0 and minus 3.53, 0. Okay, cool. I have so far vertex. Get the vertex in negative 7 here, negative 2, negative 7. I know also get the parabola open up. That point is this point. The axial symmetry gets this line passing through negative 2. I have that point, important, and this point. And another point we can get using the symmetry idea. Pero no, okay. Let's do it. Never we are doing behind. I go to Desmos. I type in the equation. And I try to find the point. Graphically. Okay. Do you see Desmos?
Yes, we can see it.
Or this is the example 1. Now you see example 2. Example 2 is this? Yeah, it's this. Okay, I copy here. Okay, I copy. This is interesting. I copy the original is given at the beginning. This. Okay, let me try to remove this, and remove this. I copy this because the given at the beginning. The point is a point. What point? Well, we determine the y-intercept, determine the vertex, and I get 2, negative 7, and 2 we are x-intercept. But remember the axial symmetry, get this line, and we can infer in easy way another point here. Symmetry with this. See, this point is 0,5, and the axial symmetry is located in -2. I suppose that the distance between axial symmetry and this point is 2. And 2 in opposite direction is -4. And the same y value que 5. Do you follow me? Yes or no?
Yes.
And by curiosity, look at that. I remove the parabola. I do another equation que I say in the piece of paper are equivalent 100%. Look at that. In different color. Bang. Do you see it's the same? So in red color, I plot the vertex 4. Y in the black color, I plot the standard, que es like is given at the beginning of the problem. Let me finish. Now come back to the whiteboard. You help me to understand the rest of the parameter that I need to find. Number 1, what do you think about domain? What is the domain of this function? Come on, guys, answer me.
Negative infinity to positive infinity.
Absolutely. Always is negative, from negative infinity to positive infinity. What is the range? Remember, range
is -7 to positive infinity.
Absolutely perfect. And in -7, you put the bracket or parentheses?
Bracket.
Absolutely, because it includes -7. Anyone following me and these students? Do you understand? Yes. Now the optimization. The optimization always happens in the vertex. Entonces, ¿es mínimo o es máximo?
Minimum.
Minimum.
Minimum. And what is the value of the minimum? What is the minimum value of the function in the vertex? Minimum. What is the minimum?
-7.
-7, the y component, at x equal -2. Super. Super. Okay. One more example. The last one. The last one of this easy before start application. Do you see my whiteboard or not yet? Not yet, no? Do you see my whiteboard?
Yeah.
Yeah, cool. Example 3, que es the last one que we are doing just the graph. Suppose this equation, h of x. This is example 3, no? Example 3. Is equal minus x squared plus 4x minus 5. Again, the same question. We have vertex for standard.
Standard.
Standard. Si es standard, si you realize, okay, yes, it's standard, okay. Now, who is A, who is B, and who is C, please?
-1 is A, B is 4, and C is -5.
Very well. Now, in what direction open this parabola? Open down or open up?
Down. Because
Down.
it's -1.
Exactly. When the A is negative, you infer que the parabola look like that. Now I need to find the vertex point. Remember the formula. The easy way is the formula. The formula is H is equal minus B over 2A. Be careful. My formula have a minus in the front, but B is positive 4, but A is -1. Do you see or no?
Yes.
And we have double negative, and double negative become positive. And 4 divided by 2 is 2. 2 positive. H is 2. In order to find the K value, oh, it's easy. You evaluate the function H and 2. So plugging in H into the function in order to get the K value, is, you know, H and K is this two components of the same point. Entonces, there are relationship between them. Entonces es, be careful with the sign, -2 squared plus 4 times 2 minus 5. Entonces it's tricky because it's not the same -2 squared and -2 squared. Do you see the difference between these? In the first case, it's -4. In the second, it's +4. Because it's -2 times is 7. So minus times minus positive. In this case, no. In this case, it's -4. Exactly like this. Plus 8. -5. No? Entonces -1, no? Because -4 and positive 8 is +4. And +4 minus 5 is -1. Okay, entonces our famous vertex is located at the point 2, -1. Okay. I know also que the parabola open down. Entonces the rest is find the y intercept and x intercept. It's doing. The formula is f evaluating 0, que you know specifically, and the quadratic function is equal c always, and c is -5 in our example. Therefore, the point is 0, -5. And the x intercept is more complicated. Why is more complicated? Because I need to solve the quadratic equation. It's doing is you copy the function, you enforce it to be 0, the y 0. Entonces you copy -x squared plus 4x minus 5 equal to 0. Entonces, our goal is now solving this quadratic equation. For solving this quadratic equation, you need to apply the quadratic formula. Minus b plus and minus square root b squared minus 4ac divided by 2. B, remember, was 4. This is minus 4 plus and minus square root 4 squared minus multiplication by negative 1 and multiplication by negative 5. Okay, see. And everything divided by 2 times negative 1. Okay, remember, always we focus in this expression. And 4 squared is 16. Ow, but be careful. We have a lot of negative in this problem. We have 3 negative, no? 1 negative of the formula and 2 negative of A and C. Both are negative. 3 negative is negative. Negative 20. And then negative 4. Entonces, square root, I need to find the formula, is too high. Minus is too high. And when you see que the solution is imaginary, geometrically means que the y-intercept you try to find do not exist. Because you are doing your best. You force it to be 0, and it's a classical in algebra. You try to find something, okay, you don't know. You set out the equation, and when you solve it, suddenly happen, okay, it's imaginary or complex. That means it do not exist. In the real field, no. It exists in another dimension, in another planet, not in the real. So definitely, we have no existence. Okay, so we are not too much information. The only information I have in my hand is, let me see, the vertex, important, super important. The y-intercept. Wow, and that's it, no? No, he opened up. So with this information, I try to do my best. I open the smooth. Let's see what happens. Okay. Do you see my Desmos or no? Yes or no? Do you see or no?
Yes.
Okay, this is example 3, no? Okay, example 3 is this equation. Okay, I plot that. Boom. But professor, you obtain only 2 points. You obtain 2 comma negative 1, que was the vertex, and you obtain the y-intercept, que was 0 comma negative 5. Okay, but I can't obtain another vector using the intuition, the symmetry. The axial symmetry, one more time, is the line x equal to, and it's a symmetric. Therefore, we have here 2 units. Actually, it's 2, no? Yeah, it's 2, it's 1, 2, and 2 in the other direction is 4. 4 comma negative 5. And the same y component. And you see clear now, wow! What is the reason? See, the vertex is located at the point 2 comma negative 1, and the parabola up and down never cross the x-axis. And that is a reason que somehow, you know, algebraically, you can see that do not exist geometrically the x-intercept, because it's impossible. Right? Super clear or super confusing? Super clear.
I have one more example.
Well, yes, but in the word problem. In the word problem. I promise in
Okay.
the word problem. Look, it's similar in the word problem. Look. Let me come back to the whiteboard. Okay. Wow, here. Do you see my whiteboard?
Yes.
Yeah. Okay, let me erase. Let me bring two pictures. Okay, prepare for the application. Now application. Application. Okay. Bam and bam. Okay. Let's do this first. Make a zoom. It's a quadratic function application. Oh, okay. This word problem talking about suppose that the manufacturer of gas clothes dryer was found that when the price is $P, P is a price expressed in dollars, y ahí suppose que P es the independent variable, o sea, es the variable que theoretical part we suppose que es X. And the revenue is R of P, so the R is Y. So we have equation, by the way, it's quadratic equation. How do you know the quadratic equation? Because you have P squared, you see exponent 2. Obviously, it's quadratic equation. And the word problem normally happens that the variable not necessarily is X and Y. In this case, P because it's a price and R is revenue. Okay, entonces now let me copy. You have a formula. The formula is R, okay, R working like a Y, no? Either way, R of P is equal to minus 4P squared plus 4,000 P. Wow, it's weird. Entonces, what do you think? This is a quadratic function, yes or no?
Oh my God.
Ahí. Putting off the microphone, please. Okay. Question number 1. Is it quadratic function or no? What is the clue que give me yes or no?
Yes, it's
It is a
squared.
quadratic function.
Exactly. This is the glue. These two es el glue, que es quadratic. Okay. Si es no two, es Juan, en línea, pero dice quadratic, es parábola. Entonces my next question es expressed en estándar o another way que es
Standard.
eso, estándar. Es estándar. Entonces, who is A, B, C?
A is going to be -4 and B is going to be 4,000.
Así.
And we don't have C.
Amazing. Es C.
Zero.
Okay, entonces now, let me try to ending the what problem is what unit price should be established for the dryer to maximize. So I need to maximize. I need to optimize. And this parabola open in what direction? Open up or open down?
Down.
Down, because it's -4. So my parabola can represent the graphic representation for this equation, open down, and this point is the max. And this is the thing I want. Find the max revenue. Entonces now remember this happened at the vertex point. And the formula is, remember, H is equal minus B over 2A. Okay, this minus B is 4,000 divided by 2 times -4, que es 6, ¿no? Now, double negative become positive. Entonces, basically, it's 4,000 divided by 8, no? Why don't you put it in the calculator? 500. H is 500. But what is the interpretation? 500 what? $? Or es P, ¿no? Remember, our independent variable is P, que is equivalent to X, and X matching perfectly with the H, es dollar. So the optimal price is $500. However, suppose I need, by curiosity, just curiosity, I need to find the revenue, so how many thousand, $1,000,000, I don't know, revenue in 500. Bueno, it's K, this is K value, this is H, and this is K. And you plug it in, this is completely out of the question. The question focuses in the price. The price is, the optimal price is $500. But what's the revenue? Okay. So you copy -4, 500 square plus 4,000 times 500. So you replace P for 500. And you put in the calculator. Again, the story. Let me try. I have another calculator that's better. So it's should do here. Okay, it's -4 x squared plus 4,000 x, and I suppose x is 500. Wow, the answer is $1 million, I suppose. Let me see how many zero. 1, 2, 3, see. 1 million. This is the profit of this company. Do you understand very well? Yes or no? You pay attention or you don't pay attention?
Yeah, we're paying attention.
I know that you do that. Do you understand very well or no? Confusing?
But on those problems, we do not have to represent the parabola at all, right? It's just...
Yeah. I have another here. Okay, about a smartphone.
Okay.
This is the quadratic function application. But in that case, they're probably talking about the marginal cost in dollar of the manufacturing X sell prices. So X is the independent variable, que is the thousands. So it's a cell phone expressed in thousands. It's given by this formula. Okay, let me copy the formula. The formula is C of X is equal to 5x squared minus 200x plus 4,000. Bueno, es obvio que es this quadratic function is expressed in estándar. Yes or no?
Yes.
And your identification que A es 5,
B is negative 200 and C is 4,000.
Exactly, 4,000. Okay, now how many cell phone, que es X, should be manufactured to minimize the marginal cost? So in this case, this is the parabola, yes or no? And this parabola in what direction open? Open up or open down?
Up.
Open up, because A is positive. Therefore, the vertex is always used to optimize is a minimum, right? And this is exactly the minimum. I need to find how many cell phone you need to manufacture to create this minimum cost. And by the way, and the second question is, what is the minimum cost? Okay. So I need to find H and K. So the vertex have two components, H and K. And this specific world problem, H is cell phones in thousand. And K is the money in dollar. It's the money, but in this case, the bad money, you know, the manufacturer need to pay to create this phone. Okay, we come back again to the famous formula. H is equal minus B over to A. I'm plugging in. Minus B is negative 200 divided by 2 times 5. Oh, this is easy by hand. Negative positive, this is 200 divided by 10 is 20. 20, what mean 20? 20 what? 20,000 of smartphone, cell phone, pero in thousand. Actually, is 20,000 cell phone. Es the último. Now, in order to find the cost to produce this, you evaluate this in 20. And the original function is 520 squared minus 200 multiplication by 20 plus 4,000. Okay, again, calculator. Guys, for me, no important the arithmetic. I suppose that everyone needs to pass this class calculator. Do you have or no? Because in the next chapter, not in this, in the next, in number 3, we are using special functions. Okay, so you need a special calculator. A special, no scientific calculator. Okay, the answer is yeah, the answer is $200. It's not bad. It's not too much to pay this $200 to produce 20,000 cell phone. Wow. Like when you sell that,
or 2,000?
it's 2,000.
Oh,
At least I have in my calculator. Let me check it out again. If I square minus 200 x plus 4,000, and you evaluate at 20. Oh, no, I make a mistake. Oh, no, I make a mistake now. It's 22, 0, 0. Yes, the answer is correct. So this is the cost. So this is nothing. I need to pay 2,000 to create 20,000 smartphone, and the price of the smartphone is, is at least $800 per each. So the profit is fantastic. The profit and the profit, and the revenue and the profit. Do you understand this or no? All right.
I'm getting a little confused on the part where it says, what is the, when the part B, this is what is the minimum marginal cost?
Yeah.
It would be.
Yeah. Okay, that point means.
200?
No, that point, for sure. You want I see in this one now. That point is the point 20, 2,000. Okay, that point is in 20 in X. Of course, 20 cell phone, not 20, you know, 20,000 of cell phone. And the cost, when you plug in 20 in this expression, I did that, is $2,000. You get the idea or no?
Yeah, I understand now because I was reading the questions. It's like, okay, hold on, what? Thank you.
Cool, no problem. Okay, guys, so now we start new section. It's long. Today is just the beginning, but it's super important and super interesting. It's about a polynomial function. Let me explain definition. Let me explain the basic idea about polynomial function. Okay, what is that? Well, polynomial function, polynomial, this word is collection monomial. And monomial in algebra, including coefficients, suppose coefficients 2, x, and we get a exponent, suppose, I don't know, 4. But monomial, always mandatory, this exponent would be whole number. What mean whole number? Whole number. Whole number is 0, 1, 2, 3, and so on. Okay, es integer number, whole number, pero incluye 0. O sea, es totally illegal in the monomial have, for example, -3 or -4, that negative number, or fraction number, 5x to the 1/2. O sea, in the polynomial, que este collection of the polynomial, you never see that. For example, one example of the polynomial, f of x equal -4 x to the 5th power, one monomial, plus 6 x to the 4th power, another monomial, plus 2 x. Okay, there you go. Not necessary to be completed 5, 4, 3, 2. No. Sometimes happen que one coefficient is 0. Entonces now one guy is missing. Okay, now important. And the polynomials, you understand the idea of the collection. What is the degree? What is the degree of the polynomial? Bueno, es, for example, the degree of the monomial is 4, que es the exponent. But in this case, in polynomial, you have different exponent. We have, for example, let me use in that color, you have 5, you have 4, and here is 1, que es invisible. Well, entonces the degree is the higher value, the greater value of the degree of each monomial. Entonces es degree 5. And you take the bigger exponent, f5, degree of 5. Okay? Now, if the degree is even number, I suppose that the graph look like that, like a parabola. We study quadratic equation. O sea, quadratic equation is particular case of the polynomial. And see, the degree is odd number. Entonces different. Maybe it's like that or like that. And the parabola, you know, we have two possibilities, huh? Open up or open down. Pero this situation happen, it doesn't matter que es degree 2, que es quadratic, degree 4, degree 6. And here is, it doesn't matter que es degree 3, 5, 7. It's the same behavior. Okay? And we define, this is the complicated part. Pay attention, please. The aim behavior. What is the aim behavior? The aim behavior is aim behavior expression. Aim behavior expression. What is the aim behavior expression of this polynomial? Well, is you take the monomial que contain the higher exponent. This is the aim behavior. Why? It's the aim behavior because this is the dominant. So everything increasing, this increasing, but this increasing faster, and this increasing super faster because the power 5 increases super faster, and this is the aim behavior. So when you have different possibilities in this specific scenario, we have coefficiency negative because coefficiency is -4, but the degree is 5, and 5 is odd number. So the graphic of the aim behavior look like that. I copy that because in the middle I don't know what's going on, because the aim behavior is the interpretation of the aim behavior is when the x represent a huge number, positive or negative, in both directions. The aim behavior is obvious que you understand que the dominant in this is this. You take this, and we have, let me try to explain the 4 possibility of the aim behavior. We have coefficient positive, a degree even. We have coefficient negative, degree even again, bueno. Coefficient positive, degree odd. So 3, 5, 7. And coefficient negative, degree odd. Entonces, the end behavior in that case look like that. Okay, remember, end behavior is I don't care too much. This part is enigma. I don't know. That part is not important. But when it's positive infinity or negative infinity in both directions, positive infinity or negative infinity is go up and go up. Not necessarily vertical, guys. Right, let me try. Let me try to do my best. The classical example is the parabola. But not necessarily parabola. Suppose that the degree is 4 or 6 or 8. When the coefficient is negative, well, I'm going down. When the coefficient is positive, but the degree is odd. It's odd. Look like that. And when the coefficient is negative and the degree is odd, look like that. Another way to express this idea is graphically. I like that way. However, there are another way is use right, up, and left, up. What mean that? Right is the x-axis, right or left, and the y-axis up, up. This is up, up. This is right down, and this is left down, and this is right up, and this is left down, and this is right down, and this is left up. Do you follow me there or no? It's a little bit complicated to understand this or no?
I think the graph looks better than the left and right, for me, at least.
Say again, what is better?
For me, at least personally, I like to visualize the graph more than the left and right. I always get confused by that.
I understand. So me too. I prefer graphically. You know, because you know, all we have again one image give me more information than 1,000 words. Graphically fantastic. I have another example. Can you help me? But this is tricky. Tricky. Look, this is example 2 because example 1 was the first I did that. Example 2. Okay, example 2 is, look, suppose the function g is a polynomial, but unfortunately somebody know me do the factorization of this. Entonces es 1/4 x paréntesis 2x minus 3 cubic and x plus 4 squared. And what's the question? Well, the question is find the end behavior expression of that function g. I remember I'm doing the graphics. It's like that. Option 1, option 2, option 3, or option 4. I have no idea. There are no more options. It's just 4 options. Okay, entonces I remember que the professor explained que the end behavior is when the x is a huge number, positive or negative. Es easy when you have expand this, it's easy because you take the higher degree. But in this case, no. Entonces, one possibility is expand this, but it's too long process. No, no good. Entonces now, in order to find the A behavior, you copy 1, 4, you copy X, but here you mentally delete this 3. Why? Because this number is a huge number. Suppose that 2X is 200 million. 200 million multiplied by 2 is 400 million. And 3 is negligible. Likewise, you delete the constant number and stay only, so stay 2x cubic and stay x squared. Do you follow me? Do you understand the idea?
So we delete the constant, so
You delete the constant because the constant is nothing. Constant is constant, flat. And 2x increasing forever. And you're supposed to find the A behavior, x is a big number. Okay, now I finish. No. I need to put 1 over 4x and times 2 cubic, is 8 x cubic and x squared. Oh, easy. This is 8. 8 divided by 4 is 2. So 2x x cubic x squared, is 2x to the 6th power. Wow. And this is the expression que indicate me the aim behavior of this expression. Entonces, according to this information, what do you think? Is the option 1, 2, 3, or 4? Remember, coefficient and degree. Coefficient is 2. Degree is 6, que es even. Number 1, very well. So the graph of this look like that. I don't care that part. Look like that. Actually, it's not vertical. I did wrong. It's like that. Finish the graph. I understand that the graph look like that. Option 1. So coefficient positive. And exponent or degree even. This idea is clear or is confusing? I suppose that you get rough idea now, but little by little in another example you see more clear. Let me see example 3. You help me. Example 3 is f of x equal x cubic plus x squared minus 9 x minus 9. Again, I need to find the A behavior of the expression f. In this case, it's easy, Professor, because when there is no factorization, I don't need to delete the constant. I take just the monomial que have the higher degree. That guy. Therefore, it's x cubed. Because x cubed has coefficient 1 positive and the degree is odd. So what do you think it look like the graphic? Like a 1, 2, or 3, or 4?
The 3.
The 3. That's all because the 3. That one. Entonces you see, bueno, okay, I understand, but I don't understand very well the utilization of this. What's the utilization of this? Let me try to complete the idea. Now, any graph, you need to find, for example, the famous y-intercept and the x-intercept. Okay, let's do it. Y-intercept is easy. Es evaluar en 0. When you evaluate in 0, the answer is 0, 0, 0 is minus 9. And the point is the point, 0, negative 9. But the x-intercept is always more complicated. You take the function, polynomial in that case, you enforce it to be 0. and you have a complicated equation, maybe, or not. In this scenario, we have x cubic plus x squared minus 9x minus 9 equals 0. Okay, so I try to do my best with the factorization of this. In this case, I realize que factorization by grouping, because we have a couple here, a couple here, and you find the GCF. The GCF, greater common factor. And the first couple is obvious, and the red couple is x squared. Do you remember factorization by grouping, guys, or no?
Yeah.
Factorization by grouping, you apply when you have 4 guys. And you separate in 2 pieces, and you find the GCF in the first couple, is x squared. After you find the GCF in the second couple, que obviously is negative 9. You have x plus 1. Now I can see again x plus 1 again is a common factor, and we have x squared minus 9. Do you follow me?
Yeah. And then you get the C of each one's individually, right?
Exactly.
Okay.
Yeah. Because remember, I convert the polynomial to equation because my goal is find the x in a set. At the point in which the polynomial crosses or touch, I don't know, the x-axis. I finished the factorization? No. Why no? Because you have here another factor gets the difference of a square. Do you remember that difference of a square? The formula is a squared minus b squared is equal a plus b times a minus b. Do you remember in high school? Yes or no?
Yeah.
Okay, entonces you factorization, difference of a square is square root x squared is x, square root 9 is 3, plus or minus. Bang! And we have 3 factors. The first factor is x plus 1 equals 0, que es equivalent to say que es negative 1, the value. X plus 3 equals 0, the factor is x equals minus 3, and the third factor is x minus 3 equals 0, que es x equals positive 3. Okay, then you have 3 points. The points are minus 1, 0, minus 3, 0, and 3, 0. Okay, so now suppose I want to do the graph of this by hand. And so now I try to illustrate the application of the end behavior. It sounds weird, but it's fantastic. Look, suppose my rectangular coordinate system. Let me try to create one. Yeah, here. Okay, there you go. This is x-axis, y-axis. Yeah, I plot the point. The point are, all right, let me see, that point. Wow. Que es 0, negative 9. Suppose que here, negative 9. 0, negative 9. Now I plot this point. Bam, bam, bam. Es negative 1, 0. Es negative 3, negative 2, negative 3, 0. And 3, 0. 1, 2, and 3, 0. Okay, so basically I have 1 point here, 1 point here, 1 point here, and 1 point here. But I know also that the end behavior look like that. Yes or no? So this graph is coming in the infinity positive, is coming here, cross it, this, touch this point. Of course, the graphic of the polynomial, guys, never you are doing like that. No, this is illegal. The graph is a smooth graph like that. Okay, entonces now you continue. You are doing your best by hand. After C1, let's do it in the decimals right now. Cross here. Now you see how work perfectly the end behavior. Look, this arrow is this arrow, and this arrow is this arrow. And you get roughly idea how it look like the graph is. Cool?
Yeah.
Okay, let's do it nice, elegant, and that's it for today. It's too much information. Let me try. So we dedicate an entire week, next week, doing polynomial function. Okay, let me share the screen, guys. Okay, shares. Switching to the screen. Demo. Okay. Do you see? You see that? Okay.
Yeah, we do.
Look at the example 1. Example 1 is the same example is x cubed plus x squared minus 9x minus 9. And we have different points because I know negative 3,0, negative 1,0, 3,0 is the x in the set 3, and 0, negative 9. Bang! Look at that. Do you see the end behavior? It's right up, left down. We have 3 important points. X in a set, I put in black color, 3,0, negative 1,0, and negative 3,0. And 1 y in a set, que es the point 0, negative 9. Ajá. Entonces now, this is elementary, straightforward example. But the problem is that sometimes we study next time the 0, o sea, the x in a set may be crossed like that or touched. But this is depending one thing we study Monday. Okay? Okay, entonces don't forget, send me the reading test today. The due date is at midnight. Tomorrow in the afternoon, I start grading that. And we have extension to do perfectly the homework. Remember, the homework is important, guys, because you study number 1, and number 2, I have reward, 10 extra points. Okay? Okay? Cool?
Yes, Professor.
We are the best in Miami-Dade College, yes or no?
Yeah.
Okay. Bye-bye, guys.
Thank you. Have a good day.
You too.
You too. Thank you.